Hi everyone, today I will introduce the SSIII Implants, one of Hiossen Implant's representative implant systems. The SSIII implant was developed based on a tissue-level implant concept to provide stable performance even in the posterior region. Before introducing its benefits, let me first explain its design features. The SSIII implant secures both mechanical strength and long-term stability through its stable connection structure. With an 8-degree Morse taper angle and an internal octa connection structure, the connection is positioned above the bone level, allowing for easier prosthetic restoration. In addition, the collar portion is designed to be positioned within the soft tissue, making it an ideal concept for a one-stage surgical approach, while also guiding placement according to the tissue level. Lastly, because the SSIII implant features a 1.5-degree tapered body, the same surgical protocol as TSIII can be applied, while delivering excellent placement performance across various bone qualities with outstanding initial stability. Let's look at the benefits now. The first benefit is that based on these design features, the SSIII minimizes screw loosening in the posterior region. Because the margin of the crown is positioned on the implant, sink down can be prevented. As a result, occlusal forces can be sufficiently distributed through the implant, which relatively reduces the load applied to the screw. Therefore, screw loosening can be effectively prevented. In addition, the wall thickness at the stress concentration area is thicker, minimizing the risk of fracture. When comparing the thickness of the stress concentration area with a TS implant of the same diameter, the SS implant demonstrates approximately twice the level of strength. Let's see the second benefit. The SSIII implant delivers excellent initial stability across all bone qualities. With an implant design optimized to enhance overall stability, it secures outstanding initial fixation in soft, normal and hard bone. When the SSIII implant with diameters of 3.5, 4.0, and 4.5 was tested across different bone qualities, it demonstrated high torque values, as shown in the graph. Because it delivers excellent initial stability regardless of bone quality, it can ultimately contribute to a higher implant success rate. The third benefit is excellent long-term stability through the prevention of bone resorption. With a structure in which the implant and crown are in direct contact, it provides excellent distribution of occlusal forces. In addition, by minimizing the occurrence of micro gaps even under external loading, it helps prevent bone resorption, thereby delivering excellent long-term stability. The fourth benefit is that gingival height compensation is possible even when the implant is placed deeply. In cases of strong occlusal force, the octa abutment can be used, which secures a sufficient contact area through Morse taper contact. If the gingival tissue is thick or the implant has been placed deeply, gingival height can be compensated for by using the octa plus abutment. Depending on various clinical situations, the appropriate abutment can be selected and used accordingly. This concludes the presentation for SSIII. Thank you.